Hi everyone, my name is Howard Wei, and today I will talk about the solar cell. In modern energy conversion technology, semiconductor devices play actual important roles. Among them, semiconductor solar cell as a key device for the directly converting light energy into the electronic energy are gradually becoming an important solution to energy growth and the environmental pollution due to their clean, efficient, and renewable characteristics. Now, the theme of our project will be solar celery. The solar celery are made of various semiconductor materials. The process of converting sunlight directly into the electricity using the solar cell is called the photovoltaic. In fact, the word photovoltaic comes from the Greek word for light and the name of the physicist Alexander Watt. The conversion process is based on the discovery made by the uh, Alexander Bickler, Bickler and the photovoltaic effect describes how light shines on the semiconductor materials such as silicons. Photo-excited electron tran- transition to the form electron-hole pairs. Under the action of the built-in electronic field of the p-n junction, the electrons and the holes are spirited and moved in directed manner, thereby forming an electric current in the actual circuit and realizing the direct conversion of the light energy into electronic energy. And next, I will share three interesting papers. The first is this paper. This paper, we know that solar energy is the main energy source used by people in space. Solar power station can collect solar energy in space. The key lies on the efficient solar cells. This paper focuses on the different generation of the solar cells. The first generation is the main single crystal silicon and the polycrystalline silicon. The technique is mature, but the produce cost is very high, and the efficiency of the single crystal silicon decrease with the increased temperature. We know in the space sometimes the temperature is very high. The second generate is the thin film solar cells, which reduce the cost by reducing the amount of the materials used and are prepared on the thin film semiconductors use different deposition technologies. There, there are types such as atmosphere silicon. Although organic materials are very low in cost, but their efficiency is only 1% to 5%. The efficiency is very low. The third generation is multi-junction solar cells. Multi-junction solar cells are the representative, which use as much as the spectrum as possible. Single junction solar cells with a different band gap sta- are stacked, and the band gap of each layer greatly decreases from top to the bottom. This design enabled it to absorb the photons in wide spectral range, thereby improving convection effectiveness. At present, it's mainly used on the ground due to its high cost, but it is expected to be commercialized. This paper did discuss the 3 to 5 majority junction solar cells from top to the bottom. Each layer has a small band gap that the previous layers, so it absorbs and converts the photons with energy greater than the band gap of this layer and less than the band gap of the previous layer. All layers may have similarly crystals uh, structures. Any mismatch in the lattice constant of the different layers will cause lattice diversion in the cells layers and significantly reduce the efficiency of the solar cell. Lattice mismatch as small as 0.1% will significantly reduce the current generated by the solar cell. The next is this paper. This this paper calls the spectral impact on the motor junction solar cell obtained by the means of components of cell of different technologies. In the field of the photovoltaic, spectral index is crucial, especially from the multiple the motor junction solar cells that are highly sensitive to spectral change. This paper focuses on how to use the effective irradiance value of the triple junction solar cell models as a spectrum index. The, the paper proposed a linear model for estimating the spectral index of MG solar cell technologies based on the prime solar technology, such as lattice March germanium-based 3G solar cell. They analyzed the several MG solar cell technologies include the different 3G and 4G cells. The results shows that even for the solar cell with significant different extra cotton efficient, the proposed method can achieve good correlations. The spectral response of the prime and the secondary technology are similar. It may be significant to use the SMR value from the reference component cells. This research provides a potential way for the standardization of the spectral measure in MG solar cell technology, which is a good significant for development of photovoltaic application. The third paper discussed the application of the germaniums of, of GE and the silicon virtual substrates in multi-junction solar cell for space use. Through the theoretical simulation and experimental research, its, its feasibility as substitute for standard GE substrate is analyzed. The simulation shows that within a specific thickness and interface recombination volcanic range, the virtual substrate can meet the performance required of the triple junction solar cell. In the experiment, the GE single junction and the triple junction solar cell were proposed um, on a medium quality GE and silicon virtual substrate. Although they show the application potential, there are some problems such as poor electronic quality of GE materials and the creak caused by the mismatch in thermal expansion coefficient. In addition, the paper also discussed strategies such as use thin structure to reduce the circle and using the embedded silicon layer to solve this problem. Embedded silicon layer can not only relieve the strain but can also use to achieve the high throughput mechanical exact pulling, help to prepare the lightweight flexible solar ciliary. And that's all. Thank you for watching.